All right, so for the first one, this problem here, you're going to need to be able to see this on the non-calculator portion of the test. So if you used a calculator to do this, you probably shouldn't have. Okay? Now, when you have to solve inequalities, I don't do it the way the book does it. I do it by graphing. Even though it's on the non-calculator portion of the test, I still do it by graphing. So the first thing you're going to want to do is convert this from a greater than equal to an equal to. So call it 7x minus 3 is equal to 4. 7x minus 3 is equal to negative 4. Solving both of those independently. Add 3, add 3. 7x is equal to 7. Divide by 7, divide by 7. X is equal to 1. Add 3, add 3. 7x is equal to negative 1. Divide by 7, divide by 7. X is equal to negative 1/7. Okay? That's the start of how you're going to do it. Now, it starts getting interesting because now you got to go to a graph. And from here, you kind of have to sketch this blind. And by blind, I mean, you don't get to use your calculator, so you don't get any kind of reassurance that you're doing it right. That's what I mean by blind. You have to just know, what does this graph look like? Well, the absolute value looks like a what? It looks like a V, right? And the 4 is going to go through it somewhere, yes? So ultimately, this is kind of the picture you're looking at. Now, yes?
They were trying to explain it to me. Why wouldn't you move it 3 places?
Okay. So if we want to get very specific, we'll draw it for real on the axis. Now, which way is this graph going to move? And it's actually going to move to the right 3/7. It doesn't move to the right 3. Now, some of you are thinking, well, that's bullshit because, damn it, that was on tape. Call Lakeland. All right. Well, that's bullcrap. Much better. Because all the ones we've ever done, x minus 3 squared, x plus 2 cubed, square root of x minus 4, these have all gone by which way this number says. This makes it go left 2, right 3, right 4, right? Look at the difference between these and this. The 7 in the front changes everything.
But what about the ones that have a 2 in front of them that you said make skinnier?
Ah, great point. What about the ones that have a 2? Notice where the 2 is. It's outside the parentheses. If the 2 were on the inside, that's different. Does that make sense? And so that's why it's different. That's why it doesn't work the way everybody thinks it does. And I think last class, and partly, and I say partly meaning all of it, was my fault. We got so bogged down in this little detail about which way it moves and how does it move and all that stuff that we lost sight of actually what the big picture was. Okay? Big picture here is that I probably, and I say probably because the Gators won this weekend, so I'm going to be in a good mood for the test. I probably wouldn't ask you necessarily to sketch this graph freehand, like sketch, on the test. I wouldn't say sketch y equals the absolute value of 2x plus 5 minus 4. I'm much more likely to ask you, probably not this, much more likely to ask you this. And put the 2 on the outside where you're used to seeing it. Does that make sense? I just don't tend to ask these types of questions this early on in the class. Okay? And because of the way it shifts and it doesn't go kind of the way you think it should go left 5, and it goes left 5 halves, and it's not that big of a deal. But the fact of the matter is, you've got to realize that this is a V. That's most important. You got to see the absolute value and go, that's a V. Now, whether you shift it to the right 3 or to the right 3/7, it doesn't matter a whole lot. I guess, on some level. Because ultimately what you need to know is that it's a V. It crosses at here and here. Now, where are those 2 points at? -1/7 and 1. Now, that's one of the reasons why I like to just say it's a V crossing -1/7 and 1. Because what happens to a lot of people, when they put it on a graph like this, they see this point is supposed to be 1. They're looking down and going, why is mine 3? Well, it's because you drew a screwed up picture. But it's okay. Okay? And so that's why a lot of times you'll see me when I'm doing it, I just draw kind of a V like that, throw a line in the middle of it, call it -1/7, call it 1, and move on. It's easier that way. Okay? Don't get bogged down in the details too much. Okay? Now, when's it greater than or equal to 4? When is it greater than or equal to 4? Well, what's greater than 4 mean? Is that above or below 4? It's above 4. So when's it above 4? It's above 4. I'll blur it. Right? This is where the graph is above 4. It's above 4 here. It's above 4 here. I feel like I'm doing graffiti or something. All right. Now, when is that? Well, it's from -infinity to -1/7. Union 1 to infinity. Yes, like shouldn't that be a bracket? Like who would not think it was a bracket? Those are brackets, you just couldn't hardly tell because my handwriting's so bad. Absolutely, it's a bracket. Why is it a bracket? Because of the equal to. Okay. Is that okay? Now, what if I asked you when's it less than 4? What if I said when's it less than 4? When's it less than 4? -1/7. Here to here, it's all less than 4. Okay? Now, here's the question. Why does this one not get a union where the other one did? And the answer is there's no break in the graph. You see, when's it less than 4 is all this area here. This is all less than 4. It's all one smooth movement. When's it greater than 4? Well, that's not a smooth movement. There's this side, and then it stops. And then that side. That's 2 different sections. So it's either over here or it's over here. That requires the union. Okay, that requires the union. All right. Any questions on that? All right. Moving on to number 2. Or moving on to the second section there. Now, we're asked to find f plus g of 5. How do we do that? Well, to find f plus g of 5, that's the same thing as f of 5 plus g of 5. So f of 5 is 2 times 5 squared plus 5. G of 5 is square root. Well, let's just do f of 5 first. F of 5 is 25 times 2 is 50. And 50 plus 5 is 55. Now what's g of 5? G of 5 is square root of 5 minus 4, square root of 1, which is 1. So f of 5 is 55. G of 5 is 1. 55 plus 1 is 56. Now, what's f times g of 1 or 5? This is f of 5 times g of 5. And I feel like I'm being pretty nice right now because I asked you to use the same numbers twice. So what's f of 5 times g of 5? That's just straight 55. 55 times 1. Now, what does this notation mean? This is f composed with g of 8. So what does that mean? Find g of 8, and then when you get g of 8, use that for f. So g of 8 is square root of 8 minus 4. 8 minus 4 is 4. Square root of 4 is 2. So now what you're really asked to find is f of 2. Well, how do you find f of 2? Take 2 and plug it in for f. Two times 2 squared plus 5. This is 8 plus 5 is 13. Okay. Any questions on that? Going once? Going twice? All right. Now, this is one that is confusing. Okay, this is very confusing. First of all, let me just get some people to shout out some answers. Somebody's got an answer. Shout it out.
Negative infinity to union 2 infinity.
Negative infinity to 2, union 2 to infinity. Okay, anybody else got an answer? Shout it out. Yeah, Wayne, go ahead.
I have from 2 to bracket 2.
Bracket on 2. Okay. Anybody else got an answer? Shout it out. All right. Jesus is always a good answer. Just negative infinity to infinity. Anybody else got an answer? Shout it out. Now, there's absolutely, positively nothing wrong with any of these answers. Okay? I mean, other than that none of them are right, there's absolutely, positively nothing wrong with them. I want to ask my friend Tori. Tori? No, I love you, okay? Not like I'm going to buy you a Valentine's gift or dinner or anything, but I love you anyway.
I want to fix my answer.
No, it's too late to fix your answer.
I want to have another answer.
No, you can't do that either. It's my game. Just give me 1 second. We're going to let you fix it. I want to talk to Tori for a second. Tori, you told me the answer was negative infinity to 2, union 2 to infinity. Now, my question for you is, why 2 pieces? And I know I'm setting you up here a little bit, and I apologize, and I love you. Why 2 answers?
That's how we did it on the last worksheet. And
That was the answer I was looking for. You can stop.
okay.
Because that's the way we did it before. And I love Tori because Tori pays attention. That's what we did it before. So let the good times roll. Just do it again. Okay? What? Yeah, there was a worksheet last time. Don't ask me for it. I don't know where it is. I think I threw it away. But let's explain when we have this answer. When we have this answer here, what does that answer mean? What does this tell us? Why do we put this? Okay? That's a fundamental thing. So remember that when we have 1 over x, and I ask you for the domain, okay, what am I saying? X can be what? Well, there ain't but 3 choices when you get right down to it. A value for x has to be one of 3 things. It's either got to be positive, it's got to be negative. If it ain't one of those 2, then guess what? It's 0. Now, when I ask you what is a positive number, what do you say? Thank you. When I ask what is a positive number, the answer I most often get is this. Well, it ain't negative, is it? And then I'll go like this. Well, how do you know if a number is negative or not? And they're like, genius, look at the sign. 8. Is it positive or negative? Well, you don't see negative, do you? I don't see a negative sign. There you go. It's negative then. It's positive. Now, how do you know whether a number is positive or negative? Well, the answer is, it's not just look up at the sign. Positive numbers are what? Give me a definition. Greater than 0. So what do they look like? All the numbers greater than 0. 0 to infinity. That's positive numbers. Right? Where are negative numbers? They're less than 0. So what do they look like? Now, what does 0 look like? Right? So when I ask for the domain, of this, what do you usually tell me? Here's what I'm saying. Can we use positive numbers? Can I put a positive number here? Check. Can I put a negative number there? Check. You can do positive numbers, right? Like 1/2. You can do negative numbers like 1 over negative 3. Can you use 0? So 0 is the problem. So the answer is, when you see me write it this way, what I'm saying, Tori, is, and I didn't do a very good job of this last time, what I'm saying is, it can be any positive number, it can be any negative number, but it cannot be 0. That's what this means. So, Tori, to answer your question, or to answer the question from earlier, I asked you, why did you write it this way? The answer that you gave me, which was a very real answer, was, well, that's how you did it last time. It can be any positive number, it can be any negative number, but it cannot be 0. That's what you're saying there. Okay? That's what you're saying. Now, let's go to my friend Wynn. What is my friend Wynn saying? Well, Wynn's saying this. It cannot be any negative number. He doesn't think it can be a negative number. He's basically only giving you one side of it. Why can we not use negative numbers? Why can we not use negative numbers? You see, let's look at square root. Let's look at square root of x. What numbers can we use? Can we use positive numbers? Check. Can we use negative numbers? No. Can we use 0? Can I take the square root of 0?
Yes.
Yes. So what do positive numbers look like? 0 to infinity, right? Negative numbers are negative infinity to 0. We can't use that. And then 0 is 0, right? So when I write the domain, what do I got to write? Any positive number, but also it could be 0. Hence, you would get the bracket on it. Okay. Now, Wynn, what do you want to change your answer to?
I want to put the parentheses instead of the bracket.
Okay. When we write this, what are we saying? It can be any positive number, and it can also be 0. That's what this means. When you see that, that's what you're saying. Now, does that work? Well, we need x minus 2 to be positive. So x has got to be bigger than 2. That's the 2 to infinity part. Now the question is, do we want to include 2 or not? Well, and the answer is no. We cannot include 0. We cannot include 2 because 0 is in the denominator then. And that would be the problem for us. So we would need a parenthesis. You are right when you modify your answer, put that as a parenthesis, and you'll have it. Does that make sense? Perfect.
I just remember how last time you did it, you put like x, g of x over top of each other, and you set the denominator equal to 0, and then that.
Here's the difference. The last time I did it, I didn't have a square root.
So if you had absolute value or something, you could just make
Absolute value would be a completely different story. Square root's the only one that's very restrictive. And of the functions you know right now, remember the domain for all those 6 functions. You remember it? What was it? Negative infinity to infinity for all of them but Square root. The square root's the only one that didn't have negative infinity to infinity is the answer. Okay. So this, in this case, the square root restricts it just as much as the fraction does. Okay. Other questions? Come on. Other questions?
How'd you get the 2?
Which two? This two here? You're setting x minus 2 basically greater than 0. So add 2 to both sides. You're setting this inside piece greater than 0. So add 2. Add 2. You get x is greater than 2. Come on, talk to me.
Okay, so if it was x plus 2 in the square root, would you set it less than 0?
No, you'd still set greater than 0 and it'd be negative 2.
Why do we use parentheses instead of?
Okay. So what does the bracket mean? The bracket means it includes the number. Okay. Let's answer it a different way. Did I press this button? I must have. Sorry if you're watching at home and you're confused. I am too. All right. I'm going to give you two sets. Call it set A and set B. And I will tell you that 3 is in what set? Which one's it in? The number 3 is in what set? Is it A or B? I feel like it's a trick question. That's a very good point. As you're watching at home, you probably feel like it's a trick question too. I'm saying, where's 3 at? And you're sitting there going like this. I don't know. I used to think I was kind of smart, and at least I thought I knew what 3 was. And you're asking me where's 3 at, and I want to tell you it's there. Both of them. And I say, no, 3 is only in one set, and you're sitting there going, the hell it is. It's in both of them. 3 is not in both of them. 3 is only in one of them. The 3 you think you see in one, you really don't see. And people are going like this. I quit. I'm done. Why? What's the difference? You see, here's the part that you focus on because you know what this one means, but you don't focus on the other part because you don't know what it means. You focus on this and this. And this thing here and this thing here are almost ancillary. Like, you don't even pay attention to those. Okay, you're just looking right past the most important part, and you're just focusing on the one thing you really understand, which is 3. What's the difference between a bracket and a parenthesis? What's the difference between a bracket and a parenthesis? That's the question. You see, the parenthesis means up to, but not including 3. So on a number line, how do I go from infinity to 3? Here's 0, here's 1, here's 2, here's 3. How do you go from infinity to 3? And the answer is, it's really hard to do. How close to 3 can you get before you touch it? How close to 3 can I get before I touch it? And the answer is, people go like this, oh, you touched it. Force field. Up to, but not touching 3. Up to and including 3. Okay? That's the difference. So when I ask you which one of these two sets has 3 inside it, the answer is only one of them. And what is the answer? Okay. Now, how does this affect the last problem we looked at? If I put a bracket on the 2, then I'm saying it's okay for this to be 2. Well, if I'm saying it's okay to be 2, I'm saying I can plug 2 in. 3 times 2 minus 2 over square root of 2 minus 2. I cannot do this. This is 4 over 0. That's a problem. You see what I'm saying? That's a real problem for me. So that's why I cannot use the bracket and I have to use the parenthesis instead. Does that make sense? Okay. I'm pausing again to take more questions. Let's look at the next series of problems. Here we go. Love these questions. Did you guys get these? No? Not only no, but hell no, right? Just no. Hell no. I didn't get any of these. All right. Let's take a look. Some people think they got the first two. What's the first one?
Bracket -4 infinity.
The first one is -4 to infinity. Why? Let's take a look. Let's take a look. -4 to infinity. Let's just look at a graph real quick that's got a range of -4 to infinity. 1, 2, 3, 4. This is -4 to infinity, yes? And that's what that would look like. All right. Now, if we take this and we shift it, and even if you want to call it a parabola and move it up this way, it's fine too. But if you take this and you shift it to the left 2 units, which is what this is going to do, this is going to shift it to the left 2 units. If you shift this left 2 units, does that really affect anything? No, it's not changing anything. The range is still going to stay the same. All right? So the range in that case will just exactly be the same, -4 to infinity. Okay? Now, how about f of x plus 2? What's that going to do? Nate? Bracket -2 to infinity. What's that going to do? That actually will affect things. Now, why? Because this is going to shift the graph up 2 units. The plus 2 will shift it up 2 units. All right? The plus 2 shifts it up 2 units. So, therefore, it goes from -4 to -3 to -2, and then it goes from there. Okay. Now, what's 3f of x? What's 3f of x? That's going to multiply every single y value by 3. Now, I'm going to go John Madden. I apologize. Some of you guys are young. I'm going to go Football Telestrator on you. Boom. We're going to zoom in on this. Let's take a look. Zooming in on the picture that you just saw. Remember I said you could draw a parabola if you wanted to, but really all you need is this portion of it. I want to look at the y values. This one is 0, -4. There's a y value that's -3, am I right? Do we agree? There's a y value that's -2. Do we agree? There's a y value that's 0. Do we agree? There's a y value that's 1. So forth and so on, right? All the way up. Okay. Now, what happens when I look at 3f of x? What that's going to do is multiply every one of these y values by 3. So the 1's going to become 3. The 0 is going to become, the -2's, or the -1, or the -2 is going to become -6. The -3 will be, the -4 will be. So how low will it finally get? What's the lowest part on the graph? -12. Now how high will it go? To infinity. So this is going to be -12 to infinity. Yes?
These take more mental work than like actually
Yeah, these require a great deal amount of mental work. The question was, these require a lot of thought is more than just kind of manipulation of some kind of expression, and the answer is yes. This is not like, a problem where I might say, solve the absolute value of x plus 5 equals 6. That's very algebraic, very, very algorithm generated. There's a set of rules you follow. This is much more look at it and react. These are hard questions.
Can you go back to the other graph?
This one.
Yeah.
What's that?
Hopefully you're in a good mood when you
I'll be in a good mood. I was in a good mood when I made this worksheet too.
Oh my god.
Okay. You straight?
I got the first two, but then like 3f of x, that's just like
Bless you. How about this one?
No, Jesus.
Say it again. 0 to infinity. 0 to infinity. This one is 0 to infinity. Don't know how. I just read in the book somewhere. All right, 0 to infinity. Let's explain how you get that. Now, what's the absolute value going to do? So let's take a look. Absolute value of 1 is?
1.
Absolute value of 0 is? Absolute value of negative 1 is? Absolute value of negative 2 is? Absolute value of negative 3 is? Absolute value of negative 4 is? So what happens? All the negative numbers all of a sudden turn out positive. All the positive numbers stay the way they are. So what happens? What most people assume happens is that this whole thing just goes up here to 4. Whoop. No, it doesn't. Why not? Well, I don't know. Why not? Why doesn't this whole thing just jump up here to 4 and just start going, whoop, there it is. Be the name of a song here before long. Why doesn't it? Because it takes all the positive values and leaves them alone. It takes all these values from 0 up to 4 and leaves them alone. All of these values are going to stay the same. And some of you are going like this. Well, what does it look like then? That's what it looks like. The range is 0 to infinity. It takes all these negative values. Takes all these negative values and turns them positive.
Why?
That's the absolute value takes negative numbers and makes them positive. What the hell? Say it again. Watch this one.
Where would that point be on the x-axis?
Remember the other one was this.
So you just stop.
So what happens is all of these pieces here that are negative turn to positive. Any piece that was positive already will stay that way. So it's 0 to infinity. Okay. All right. For those of you that are watching at home who weren't here today to see it, I'll let you go ahead and press pause before I give the answers. 3, 2, 1. All right, here you go. So, negative infinity to negative 2, what does that look like? Negative infinity to negative 2 would look something like this, right? Now, this has got a bunch of y values on it as well. This one's negative 2, this one's negative 3, negative 4, negative 5, negative 6, negative 7, so forth and so on, right? Those are all the y values, yes?
Wait, I have a question. Why
Yes.
did it go down?
Negative infinity.
But why didn't it go the other way?
Well, it could have. That doesn't matter. For the y values, it doesn't make any difference whether you swing it this way or the other way. We're talking about the y values.
Negative 2 is,
We're talking about the range, right?
yeah.
So really all we're talking about is that it leaves negative 2 and somehow goes down. The direction at which it goes down is the domain, and it doesn't really make any difference because we're not dealing with the domain.
Be on the x-axis, the -2, because -2.
The range is the y values.
Yeah, but the 4 and the one we just did was in the x place.
Uh-uh.
Yeah.
Yeah, it was 4 was
It was -4 to infinity.
yeah, and now this one's -infinity to -2. You know what I'm saying?
Yeah, but this is not this is interval notation. This is not xy. Okay, that's interval notation. That's just for this. The question is dealing with this notation. This is just a starting point and an ending point for the y. Okay, it starts at -4 and it ends at infinity. Okay. Now, so what does -2 do then? -2 is going to multiply all these values by -2. So -2 times -2 is 4. -3 times -2, 6. -4 times -2, 8. So what's happening? This is going to start at 4 and go to infinity.
Why infinity?
Because negative times negative is positive. Okay. Now, what's going to happen here? The +3 is going to shift the graph to the left 3 units. That's not going to affect the range at all. What's going to affect the range? Subtracting 1. So what happens? The range becomes -infinity to -3. Okay. And then what's the absolute value of f of x going to be? Nope. 2 to infinity. Why isn't it 0 like the last one we did? Look at the last one. The last one went from -4 through 0 and then on its way to infinity. So it actually crossed through 0. Look at this one. Does this one cross through 0? No. So that it would never be 0 then because it didn't cross through 0 to start with. Okay? Because the absolute value of -2 is +2. The absolute value of -3, +3. -4, +4. It's just getting higher. Okay. All right, we're out of time. We'll try to do better next time. Until then.